My name is Inderpreet Singh and I am from Electronics and Communication branch.
My name is Gurmanjot Singh and I am from Electronics and Communication branch.
My name is Atul Grover. I am from Electronics and Communication branch.
My name is Maneet Kaur and I am from Electronics and Communication branch.
My name is Tushar Gupta and I am from Electronics and Communication branch.
This is the project setup for IoT based arrhythmia detection system. The project showcases node-to-node communication between two remotely placed microcontrollers. It consists of two halves, one being the transmitter and the other being the receiver. Moving to the transmitter part, the transmitter section is made up of various sensors, first being the ECG, second being the heart rate and SpO2, and third being the temperature sensor. All the sensors are further integrated and connected to the Arduino present at the transmitting end, and it is further connected to the NRF24L01 transmitter. Powering up the whole setup is the 5 volt DC power supply. Moving to the receiving section, we have the NRF24L01 receiver connected to the Arduino, and further the Arduino is connected to the LCD display which displays various vitals, and the data is sent to a local computer connected which further processes the ECG signal received. Now moving to the demonstration, we have an individual whose ECG signal is recorded. The probes are placed at the designated positions which help in collecting the ECG signal, and furthermore various vitals are also collected. The data collected is sent to the Arduino and from there to the receiving end via radio communication with the help of NRF24L01 transmitter. At the receiver, the data is received on the NRF receiver. The data received consists of various vitals like ECG, pulse rate, SpO2 and temperature. The data is then sent to the Arduino present at the receiver. The ECG data received at the Arduino is further processed and the vitals are also displayed on the LCD display.
Once the ECG data samples are received at the receiver system, it is further analyzed for detecting hour peaks and heart rate classification. For this, we are using MATLAB algorithm based on discrete wavelet transform. The dataset received is uploaded on MATLAB. On running the program, we will choose the dataset that is to be analyzed. Now, we are required to input the sampling rate. The sampling rate for the ECG sensor used in this project is 170 Hz. Figure 1 is the plot of the ECG signal that was received at the receiver system. For the detection of hour peaks, frequencies related to hour peaks must be preserved, while the others are supposed to be suppressed. Therefore, a bandpass action is required. The methods used for the same are undecimated discrete wavelet transform and Simlet 4 for wavelet decomposition. Figure 2 and 3 represents the undecimated wavelet transform of the fold level that is determined using Simlet 4. The coefficient A4, D1 and D2 are not used to obtain the bandpass filtering because A4 is an approximation coefficient and all the low frequency information is carried through it. D1 and D2 are also not taken into account because they contain information of the high frequency components of the signal. Hence, to achieve bandpass filtering and for hour peak detection, only D3 and D4 are used. Figure 4 is the plot obtained by inverse discrete wavelet transform by considering coefficients D3 and D4. It represents the signal that has well preserved hour peaks. Figure 5 represents the hour peaks that are obtained. The number of heartbeats are found using the length of the location of hour peaks with reference to time interval. This is further used for calculating the beats per minute, that is the heart rate, which in this case is 71.34. Hence, on the basis of its value, heart rate can be classified for ECG. Here we can see that the heart rate is normal.
The heart rate at rest is between 60 to 100 beats per minute is considered normal. If the heart rate is above 100 beats per minute, then the condition is called tachycardia. If the heart rate is below 60 beats per minute, the condition is called bradycardia. Our project aims to provide cheap, accurate, and user-friendly IoT-enabled heart monitoring device which will monitor person's health remotely.